Hi guys, this is Nate with Reach 3D Printers. Today we are doing the milling mod. For milling, let's see, unplug your power. For milling, what we're going to do is a couple things. We're going to go ahead and pull the hot end off. And we got our clamps. These clamps are for the Dremel. I don't have the new version ready. I have the actual device, but it needs to be designed for the less expensive Walmart version. One thing I should note about these things, if you read the instructions on these Dremel tools, it says that you're supposed to run these at like a certain speed from, you know, up in the air to get the grease to flow down the tool and to fully grease the shaft. So that might be something that you want to make sure and do so that you don't overheat the flex shaft. If you're running it for like an hour doing a milling procedure, it can definitely heat up. And you're also not supposed to over grease it. And then one other really important detail is if you had this thing bent like this, that's just too fast of a bend. You're supposed to have a 6-inch radius minimum. So 6 inches is like a dollar bill. So you're looking at a 6-inch radius. That's 12 inches. Something like, I'm not sure if that whole thing's in the picture. A bend like that slow is what they recommend. If you know what I mean. Something like that. So you may have to hang your Dremel or angle it in a special way to prevent it from, if it's too tight of a turn, it'll actually start heating up and it will melt the sleeve. So without further ado, we are going to go ahead and switch out the tool. Hopefully there'll be some quick change tools down the road, but at the moment this is what we're working with. You'll have to remove both the bottom and the top nuts to get these to work. Let me double check something. Yeah, should be good. All right. I start by loosening the nuts. I start with the top, just so I can get all this stuff out of the way. You would also have a proximity sensor here, but on this model I didn't actually install one, but I'll have one installed when I finish this video. I think I'll have some kind of a proximity set up, and these can kind of if they bend too far, it shouldn't have that problem with the end stops, because this has no end stops either. If you notice, this is a 0 limit switch, but see the bend on that? That's because they're compressing so hard that it's warping around this thing. But with the end stop, it doesn't compress that hard. I just over tightened it at one point. Again, you're going to take this guy, spool holder, flip it sideways, and rest your parts over it. Hopefully you guys can see everything going on here. Alright. So I think the top ones move to the bottom, and the bottom ones, no, it doesn't matter. Okay, you can leave the top ones where they're at. With this setup, if you can, I'm just going to triple check that. Yeah, so the clamps are exactly the same thickness, so it all kind of comes down to making sure that the clamps are, the smaller hole is at the bottom and the bigger one's up top on this guy. Now, the large clamps reduce in diameter as you go down, so it's going to clamp on like that basically, and back one also reduces in diameter, so that holds there. The bottom one is for the Dremel, is specifically it's like perfectly shaped for it. And so the top clamp should go on second, because I'm not exactly sure how high it goes, but the bottom has to be perfect. So when you actually go to install, go ahead and just grab both of those. You just loosen it up a touch, it'll go faster. So you've seen this process in the build video. Slip the wheel on, slip the spacer on. One other thing about this is if you put the wheel in position, like up into the slot, and then send the bolt through, it's a lot easier to get in there. If you come at it from, if you set these all the way to the back and then stab the hole through there, I guess that didn't work too bad. It seemed like at one point I had to put the wheel up, then send the bolt through, because there was too much tension. Maybe not on the bottom, but the top ones. Moving along. So the smaller hole is for the bottom, the one with the smaller opening. And then the bottom of the Dremel is wider, so this goes first. And then go ahead and set the Dremel. I mentioned in the video that some of these tools had too long of bolts, so I went from M25s to M20s, and they were silver. So that was also for the laser. I'll have to pull these out. This was a build that I did before, so I'm gonna stop the video. Alright guys, we're back. I had to switch out these two top screws, so we got those swapped out, and we're getting ready to throw on the top guy. Actually, we're going to go ahead and put this one in place. I know that the top is larger, top side is larger, and the bottom is larger here. So I'm just going to push it into place, paying closer attention to how the bottom sits. That's what's most important on this. And follow in with the bottom second. Major part goes up top. I'm going to go ahead and secure the top one. I think these should be long enough that it might, can't say for sure what I'm going to do with homing on this, because I mean there is room behind this to put in the homing switch, but I'd have to space out the back one and the bottom ones. So I'm sure I'll have a solution by the time these things ship out. It wouldn't take much, just a couple of small little washers to be placed behind all 4 points. Except for this one, the thickness of the end stop right there. So that shouldn't be challenging. If you're going to do the shop vac, this is what I designed for the shop vac nozzle. Coming at you. So it kind of straddles, this curved part right here kind of straddles across the clamp, and it's a little bit out of spec. I'll probably have to resize the main hole just a little bit. It only goes in a very small distance, but it goes in enough to definitely secure it. I mean, you know, it's on there. So so it can be used at this point, but how that would work is it just places right over those I don't know how strong these supports are. I've actually never used it, but it looks like it should work. So we're gonna do this without that though. I'd rather do what I know for a fact. Now, like always, when the bottom wheels get loosened for changing out tools, you're going to need to loosen these top ones just enough to make it movable. When the bottom ones get loosened, you're going to need to reset the wheels in position. So I think redesigning quick release clamps would be awesome. That would make, I mean, I don't know how many times people, I mean, typically it takes a while for you to learn a system, the ins and outs, and really get a feel for what you're doing. Okay, I put a slightly tightened, these are loose at the moment. I'm going to do my wheel compression where I lift with my finger, I lift up and push these together, and then while I tighten, I lift the wrench as well. Hopefully we can take out any carriage play that's in there. Do it on this side. Okay. These should be loose or tightened down a little more. Ah, okay, so this isn't moving, but this guy is. So this back one needs tightened as well. It's always good to kind of check your system every once in a while, make sure everything's nice and snug. Yeah, it's good. I'm not hearing it anymore. I'm definitely putting some forces on these, so. And I mean, these tables, I know some people look at this and it's like the whole thing's mounted only right here. How much pressure can this table take? Well, you know, you wouldn't want to put like a 45-pound object on here. I mean, your springs are going to compress to some extent before your table like fails, and that would be quite challenging for it to truly fail. And some have also questioned about, you know, how strong is this arm? Well, it'll bend, but I'm probably putting 15 to 20 pounds of pressure. It's actually forcing the lead screw to rotate. But yeah, I mean, there's definitely going to be limits to this system, that's for sure. So I don't think anything we're doing with some light milling, if you run it slow enough, yeah, you know, maybe like an inch every, travel like 1/1000, 2/1000. If you go like an inch a second, or like 20 millimeters a second, 25, you're not going to have any problems. As long as you don't drop into a solid sheet of wood and try to run sideways. You want to do a layer at a time, like a millimeter thick, and just slowly work it. If you're doing like PCB, I mean, you could take the whole entire surface of the copper if you have a good quality bit. I'm also going to test these guys and see the difference between a $1 pyramid, or $1 or $2 for a 60-degree pyramid engraver. So that's like a buck or two times 10. It's like, I think it was like 15 bucks for all those off Amazon. And then this one I got off eBay. This was like $20. I wanted to get something that was intended for PCB milling. So this one I'm guessing is going to give us fantastic results. So hopefully those Yeah, I can show you up close. I think I already showed you guys this once. Maybe. Come on. Well, anyways, you guys see it. You guys get the drift. Okay, I'm going to secure this with some tape. You may want to put like a piece of wood under this, just in case you plunge a little heavy or something. It's always good to protect this aluminum surface. So I might do that, but I'll go ahead and set that up in a few seconds and finish the video. Until then. Hey guys, we are back. Now we're going to install one of these pyramid bits. So I pulled off the coupling off of the Dremel. You'll make sure that you get this little piece here is called a collet. These are all 1 inch shanks, so they're a little hard to find in the 1 inch, but all Dremel is 1/8. That's what I'm looking for, 1/8 inch. I would put the shank all the way in, getting as close to the cutting edge as possible. That way, I mean, most of the clamping force is occurring right here for the tool, all the clamping force. So you want to keep the cutting tool as close to this guy as possible. So this little button here is to lock the shaft. Then you're going to want to just tighten it up a little bit. Fairly tight really, but that should be good. We can go ahead and do a test on the Dremel itself, just to make sure that it rotates cleanly. So for your Dremel tool, I don't know if I'd run it at full speed to start off, 50% speed or something. And you also need to remember this flex shaft, you don't want to let it bend a whole lot. Helps if the tool's plugged in. Might want to wear some safety glasses, flying chips of wood, all that. Yeah, that's going to be a pretty broad cut. I would say this cut is almost producing a full millimeter. You guys might not be able to see that very well. Here, get some contrast in the background. Maybe too close. I don't know. Yeah, I would say it's cutting probably around a millimeter width. So that's pretty wide for the engraving bit. To PCB engrave, it's probably too wide. But we're going to go ahead and try it anyways. Next is software. So we'll run over and take a look at software. Hi guys. Now we're going to begin the software side. So I just opened up Inkscape. Go to the new document here. Go into your document properties, make sure your default units are millimeters. I don't think there's a preset to ensure that. So changing to millimeters is always good. We're going to create a PCB path. So how I'm going to do this, I'm going to zoom in pretty close, maybe at 15 and 15 millimeters, I think is about where I want to start the hole. If you notice in the bottom corner it says ellipse. If I want the PCB to be about 3 millimeters, or the pad to solder to, about 3 millimeters in diameter. So here's what we got. Now I'm going to do this one more time. starting at that center point. If you hold down Shift and Control, it's going to create a circle or ellipse from the center point. If you don't hold that down, it's going to basically give you anything it wants to. We're going to make a very small interior hole as well. And then we are going to take this guy, and I found fill and stroke. It's right here. If you right click on the object, you can click fill and stroke and it will give you this fill and stroke tab. So for the outside one, we're going to give it a solid paint. Make sure your opacity is all the way up. And you notice the center one disappeared, but if you drag around the whole thing, you can see that tiny square in there. The next thing we're going to do is go and find difference of the path. That was under the path, and you have to have both of them selected. So I'll leave a tiny little opening there. The next thing we're going to do is get a little square, and this is going to be your trace. Let's see. If it's not perfectly set, there's a few other ways to get it like everything flawless, and that is done by using like align and distribute, if I can find it. Again, Inkscape is just not my, there it is, align and distribute. It's under object at the bottom, so you can bring up this toolbar and say, well, I want this vertical column even with this. Oh, I think it finds that, so you can line them up like vertically, so they just reposition that one. I'm not sure, I probably should have done that for the whole, but I'm not trying to make this like flawless. So then you're going to copy the bottom section here and paste it and throw this up top here, fairly even, and then we've got the whole setup. We can do align and distribute again, and then it should be fairly lined up as far as that's concerned vertically. With the whole thing continuing to be selected, you can go into, it's important to note that this center trace needs to extend past the circle. So because we're going to do what's called a union, so it's going to merge that path to this path, and that's, we filled it with 100% infill except for the center circle, but that was done thereafter. So make sure you kind of get that correct. Let's zoom back out. We see that we're located 15 millimeters, and I guess that's about 15 down here, up to 25-ish. Now you're going to select this whole thing, path, object to path. So it kind of converted something in the background. Now you're going to go up to extensions and G-code tools. Now these are already preloaded. Whoever built this plugin, I think it's some guy in Russia. Whoops, I went graffiti. You don't want to go graffiti. Extensions, well, he did a pretty good job for it being open source and all that, but I want to go into engraving on the G-code tools of the extensions. Engraving. So start off in preferences. Name your like PCB LED. We'll call this 4, because I always have good success when I call stuff 4. The 4th iteration. We're going to place this in desktop mill, so you may have to type in C user owner desktop mill, whatever, to get the file where it needs to be. 5 is your Z height, so it's going to raise up 5 millimeters and then travel over to your cutting location and begin the cuts. We don't need any post-processing because we're going to do anything we want to in Repetier at the end. Under options, I don't scale anything. Minimum mark radius 0.05. I don't know. There's probably things that could be improved. Accuracy factor, it was defaulted at 4, so I'm just going to leave it as is. 175 on the smooth convex corners. Maximum distance for engraving, millimeters per inch. I'm not really sure. That probably has something to do with when it should lift and come back down to do more intricate work. I do want to do the draw additional graphics for the path, and then once you're good, now if you try to hit apply when you're in the preferences tab, it does not work, so you'll get an error. So go into the engraving tab, then hit apply. What it's going to do is it's going to say you don't have your locations set up, your orientation points, so they're going to throw in some default ones at 0, 1, 0, 0, 0, 0, 100, something like that. And then you don't have a cutting tool defined. You can do that separately, but I don't. At the moment, I haven't really done it. And then they're going to assume that it's a 45-degree cone to cut with, so just hit OK and you'll see them pop up. And you're also going to get a tool, a big green tool dialog box. Alright, so we're going to go ahead and close that. We'll open it again in a second. So we're zooming out. We're going to grab this guy and move it off of the cutting surface. The next thing we're going to do is, it already attempted to cut that, but our values aren't correct. They're thinking the tool diameter is 10 millimeters. So we're going to delete. Make sure you still have this guy. Go into your text over here, and you got your text tool. Change your diameter to like a 0. Oops, make sure you're on there. 0.2 or something. Your feed. We're gonna drop that down. I just want to slow everything down. The shape, that has something to do with the tool shape. I haven't messed around with this enough to know for a fact what's going on here. Penetration feed. I'm thinking slower the better. You don't want to drop into that so fast that it's rough. So 60 millimeters per minute. Depth step. That's pretty much all I mess with is this upper section. Diameter of the tool, your feed rate, your penetration feed, and I guess passing feed is like how fast it moves. I'm not really sure, but that typically serves me well enough when I set those. So we're going to reselect this guy and go into your G-code tools again and go into engraving. Everything should be where it was before. You can double check it. We call this 4. It's on the mill, on my desktop in the mill folder. 5 millimeters high, engraving, I don't even know. So just hit apply. Everything should still be the same. Okay, it's still saying no shape, 45-degree cone assumed. Well, I think we have a 30-degree cone, but we'll just say that's good. That's probably going to apply down the road when you're doing 3D milling, but when you're doing single pass stuff, it's gonna determine the depth of the cut and maybe move the cutter out far enough to handle it. So here's what we got. This is a pretty fine little section, and it's going to try to cut on the outside of the black. I believe that's what it's attempting to do. These arrows are like your paths that it's taken. You can see that that blue one is going down, so it's going to like go around this way and then go back up. And it's important that those blue arrows are where it's at on the cutting surface at 15 millimeters. 15 millimeters is at the bottom. So that should have already generated the code. So we're done with Inkscape. The code is in the milling folder, and it was called 4. So that's the first one I created, and then 2 minutes later I created the different one with a smaller diameter tool, with lower feed rates. So we're going to go into Repetir, and we're going to load that. It's in the mill, 4, 2. It says 8 seconds. Again, we're coming to this issue where it doesn't recognize these parentheses as removing, like what do you call that? Well, anyways, I just kill all that. I think there was a G21 in there, but it's no big deal. Then I select up to the, except for the X0, Y0, because I want it to return. If you had homing at this point, you would say, you would put in like G28 and then G29. Now, I don't have the sensors in, the sensor and the end stops, so G28 and G29, the auto leveling. Actually, I wouldn't even do auto leveling. it might work on this. It depends how you ensure that your surface of your bed is good. If you're doing PCB with copper clad plate, then auto homing probably would work really well. But you'd have to make sure that the areas that you're probing to feel out are all within that plate. Otherwise, it's going to go beyond the plate, search for something that's not there, and throw off your results. So since we're not doing this without any end stops, we're getting rid of the auto homing. But we'll be able to get that correct. So go ahead and save it. I save it up here in the G-code editor. I think you can save it in the print preview, but since we're not doing homing, I don't think that matters. On the desktop, we're going to go PCB test. We're going to call this 4. Test PCB 4 as a G-code and save. All right, so these codes are really short. PCB 4, it's right here. Test PCB 4. So then you're going to throw in your SD card. It's gonna give me my crazy warning because this computer is a little funky. My good computer crashed, so I'm trying to do everything on a brand new system. Okay, so we're copying PCB4 and we're pasting it right here. I did some other tests just to make sure that everything was lined up how I wanted it to. And then once you've got it in there, you're going to eject it. Safe to remove. Alright, and we're going to move on over. Laser cutter. Good stuff if you have two. Alright, that's a pretty good position for you guys to see everything. You can see that I've made some changes over here. What I've done is leveled the bed by dropping the gantry, the cutting tool, down to the surface, and I moved it back and forth and adjusted the screws. And this is the old way to do leveling. You just want to get it at the exact same height on the same plane. So throw in your SD card. It should just reboot on its own. The last code I ran, it left it at 5 millimeters height, so it should drop down right at the surface. So we're going to run a quick test without the mill running, and it should just do the whole part right above. So PCB4, and we go. So if you don't move the bed or this surface, it's going to come back to 0, 0, 0. So you can do multiple procedures over the exact same one. So basically, I think now it's getting ready to do a plunge. I think a single dot. Yep, did a tiny single dot. Maybe it just Now it's doing the second one. And I've got this at 208% feed rate, so it's moving way faster. But if you run it dry like this before you actually do the PCB milling, then you'll get a sense of what's actually going on. I'm going to run that one more time just because I want to show you the trace it's doing. I'll speed it up a little further. Okay, so it's dropping down. It did half of a circle, came down half a circle, finished the upper half, and then left. So it looks like the code is good. We just have to insert this guy in here and turn on the mill. Also, we don't want to mill all the way through. And then it went and did a plunge and then another plunge. We don't want to mill all the way through this, so our height is going to be probably critical. If you want to make sure you're down at 0, you can, just to make sure that the printer knows where it's at, you can go into, what was I at? Prepare, scroll all the way down to move axis, move 1 millimeter, and move your Z down. It won't go any further than 0. I believe it has those built in once it's identified where it's at. So if we don't want to mill that deep, you can just, I mean, you can turn off the stepper motor, but you can like just manually set it there. And in milling, there's a lot of just manually setting stuff in place. So I look at the cutting tool and say, yeah, that's as deep as I want to go. So now all I really need to do is just toss this guy in there. But to get him in there, just go to prepare. Now we're going to move the axis 10 millimeters. Oh, no, you can only do the Z-axis in 1 millimeter increments or smaller. So we're just going to get them up out of the way. I don't think this is necessarily the way to do this, but why not? Let's give it a shot. I'll record over this if I don't like the results. This is definitely not the practical method, but it's fast. That way you guys aren't. Question is, will it be able to hold in position? Nah, this isn't practical. Don't do it that way. Let's go ahead and pull this block off here. Let's do it the right way. I don't know if this is the right way, but this is the way we're going to do it. It would probably be best to have like clamps that hold these down, and some kind of table system with like interlocking pieces. My brother Keith was talking to me about doing these 2020, but do like a 2080 and do like 2 slats, and that way you can have like a bed built on this that has like running sideways. It has T-nut slides so that you can actually do realistic clamps. So the whole bed surface would just be, you know, like a 2080, 2080 extrusions. I think that would be pretty cool, actually. Do it as like an extra kit down the road, as like an add-on or something. Alright, so this is the quick and dirty version. Alright. Now we're going to have to bring, wait, where was that? That was at 8 millimeters high. So back to prepare. Move axis 1. Move the Z. Get it down to 0. We're going to disable steppers. I'll show you why. I'm going to set the depth over here. Yeah, that looks like it would go through the copper. I think that looks about right. Okay, so once you get it where it's just below the surface of the copper, perhaps I can. Yeah, it's not all the way through it or anything, but it's definitely past the copper. If your table is really level, you should be okay. So now we're going to move the Z back up. Move axis 1 millimeter. Z. Move it up to like 8 or something. Now it knows it's at 8. It thinks it's at 0, 0 on the Y. So if you had a starting point, like an origin that you wanted to get this to. Happy Pi Day, guys. If you had an origin that you wanted to orient this to so that you know that you're in the right spot every time, you could actually 0, 0 out on that one spot with your tool bit, right? Okay, so we're at 8 millimeters. It should bring it back down to 5. And this is ready to go. So don't forget to turn on your cutting tool. I want to run this thing dry. And wear some safety goggles. I'm just using the laser ones. And turn on your cutting tool. maybe a little faster. My feed rate was way high. Make sure my feed rate's low enough. Okay. Now we're going to go ahead and tell it to go. Click. PCB 4 and go. So drop down to 5. Heading over. There it goes. Way too deep. Okay. Well, it's a clean cut, but it's not what we want. These tools are just too wide. This creates way too wide of a cut. So we're going to switch out tools for something a little better, and we'll be right back. Hi guys, we are switched out for the true PCB milling bit. I took off the little plastic collar because I wanted to get the bit as close to the collet as possible. So I'm just bringing this down manually. The motors are off, and I'm bringing it down to check the depth. I'm going to try for the smallest depth possible, and that way I can get the finest traces possible. So it's hardly touching it, but I'll be able to repeat it and drop this down just a little further if I have issues. Oh, sorry. I just realized that the screen said I was at 5 millimeters because I didn't return to 0. Let's see. Prepare. All the way down to move axis. 1 millimeter. Z. Make sure you got enough room that you're not going to smash into the board prematurely. Okay. Axis, prepare, disable steppers. So now I can easily move this. Set your depth. Yeah. That's about as little as I can go without it messing up. Okay. So we're gonna go back to prepare. Move axis. 1 millimeter. Do your Z. Take it up to 5 or 4 or whatever. It'll automatically tell it to move the proper height of 5 before it starts. I think I'm going to you know what I'm going to do? Just for the fun of this, prepare. Move axis. We're going to move this on down. We're going to move it in smaller increments. This should be interesting. So I'm going to flip on make sure your safety goggles are on. I'm 1 millimeter above. See how close we are before it actually starts hitting. This will also be a test to make sure we go through the PCB. Going over to move axis, 0.1. If you don't use the screen fast enough, we just hit PCB. That's where I want it. It's way too deep. Okay. So what's happened is I made a tiny little, very tiny little spot. That should be the width of the milling that I'm doing. And that's also going to be our new origin. So it should return 5 millimeters above that spot when we come back after the cutting is finished. So at this point, we should be able to just print from here. Make sure your glasses are on and your mill is running. Make sure we go to PCB 4. So mill running and then enter print. Okay, it's raised. It's heading out because it's going 15 millimeters. Actually, it's going higher, 25 millimeters at top. Feed rate slow. Yeah. Yeah. Gorgeous. Yeah. Now, if this were a drill bit, you could run the individual code to hit those points separately, and you could plunge all the way through the PCB. You just have to run 2 operations at once, or back to back, or whatever. All right. Those are some, it's pretty fine in comparison to the other stuff I've been doing. Let me get a tool to measure how fine those cuts are. I mean, they're about as thin as my fingernail. It's pretty intricate. Hold on, I'll be right back, guys, and we'll get a voltage multimeter and check to make sure it's not continuity doesn't cross. Alright guys, I'm back. Continuity here. Well, let's do it this way. This multimeter doesn't have a beep to it, so there we go. Alright, so we're checking to see if we've got a problem. We do not. Looks good. I'm in that tiny little hole right there, and we have 0, but if I touch the other hole, there we go. We're good. No continuity. Of course we do up there. So we did it. We got it. These are clean. Cool. All right. Well, that is our first successful, like really accurate procedure. I wish I could compare something to show you the accuracy of it. When you look at this and you say this is 20 millimeters, or even 10 millimeter, no, this is 20 millimeters across. I mean, that's when it comes to doing some in-home, when you're doing in-home PCB milling, I mean, that's pretty accurate. And the cool thing is you could repeat this over and over and over. That's kind of the beauty of this setup. You can actually plunge this guy back down. Let's go to prepare, just for the fun of showing the consistency of it. Drop the Z motor. Okay, we're in. I'm not even gonna run the mill. That's how confident I am in this thing actually repeating its exact same steps. PCB 4. as long as I'm on the exact same path. See what I mean? I'm not even running the mill. And it's actually down inside of that. Looks like it picked up a few little pieces. So you could see how it could definitely repeat procedures over and over and over without having any issues. So there you have it, guys. PCB milling, the crude, basic way, but the key to getting really clean results was a good bit. I mean, this bit is a must. I think I looked up PCB end mill specifically, so this is designed for PCBs. Alright, hope you guys enjoyed. Hopefully I can get this up on the internet before too long. We'll probably go into 3D milling down the road. 3D milling where you're actually doing like curved surfaces. When I was first starting out testing stuff, so that's one of the versions I did. This was some milling in, I was doing like a face and pocket cuts, whatever. Oh, that was the other one. So these are 3 different milling procedures that I did. Letters are super easy and fast because it's just like PCB milling. You drop in to the same exact depth, you do your path, you come out, and you just keep doing that. 3D milling is more way more complicated. There are some options to do, like I did this one really rough for the video, but you can do some really nice smooth stuff as well. Alright, hopefully you guys enjoyed. Let me know if there's anything else that we should run or do or whatever. Thanks, guys. Bye.